be discussing the requirement and concept of LSR injection molding, how LSR injection molding differs from traditional thermoplastic injection molding, the benefits of runnerless molding and reducing waste with cold deck technology, the key considerations and unique features required by cold deck design for the successful runnerless molding. I will now take the liberty of inviting Mr. Rajan Kasi. He's a VP South Asia Husky Technologies. Rajan is an accomplished engineer with over 25 years of experience in the mold, tooling, and processing industry. He has held a variety of roles supporting customers, adding value to clients' manufacturing processes in several countries, spanning SEA, SARC, and Middle East. Rajan's deep knowledge of process materials have earned him many accolades. He is the VP South Asia at Husky. Rajan holds a master's degree in engineering from the University of South Australia. Over to you, Mr. Rajan.
Thank you. Good afternoon, everyone. Welcome to this important and very interesting LSR runnerless molding session. So today, here myself and my colleague Balaji also here. So he will be talking about more into LSR key technologies and the way forward. Yeah, Balaji, you can start to present that LSR tech.
Hello, everyone. I would like to take over this responsibility today to present about our LSR.
Thank you all joining this afternoon time. So we will take you important things, leveraging the liquid silicon rubber, which is we call this LSR. So the LSR is a new thing which is coming to the market, which is have a variety of the products, start from medical and electronics, and even today's automotives also started to inquire about the LSR implementations. Let me quickly explain myself since already we got an introduction. So let me jump to the next slide, Balaji, which is about Balaji introduction. So Balaji is like kind of 31 years molding experience, which has a variety of technologies. He hold tooling experience and molding experience prior to Husky, and with Husky he has a lot of hot runner processing technologies. He has a very nice tool and die background, which is almost like over than 30 years in this field, which is the right fit for presenting this material to you guys. So he's based out of Singapore and he's supporting to all other South Asia region. Just a quick intro about company overview. Husky is the Canadian-based MNC. Proud to say that we are the largest integrated injection molding supplier. Husky is the only company doing a machine mold, hot runner, and automations. We have a strong history of innovations. We do like innovation based on the market needs, and it's not only the needs, even the being forthright, we will do many of the innovation which is going to be coming into the market. We part of the platinum equity. And we have been involved medical projects since 1960. We have been delivered more than 25,000 systems for the medical product hot runners. We also do a lot of device and pharmaceutical. And you take whatever the critical molding application, Husky will love to do that, and we are part of that. Next, Balaji. So based on the locations, we do have a manufacturing location, one in US in Vermont, and Europe in Luxembourg, and for Asia we have two, one in Shanghai and one in India at Chennai. So coming to Chennai, so we have a 20-acre land at this manufacturing facility. We do the hot runner manufacturing and controller manufacturing. Also we do the global design engineering and global solutioning, where we do the application and mold flows, and also we keep it as a SARC part center. This facility called as the global manufacturing hub, and we do the export more than 50% to other than India parts. Next slide. So coming to the today presentations, so we know about the Husky technologies and also understanding about the LSR and the benefit of the direct gating with the LSR, and also it's very important to understand the features of cold deck technology. So prior to the LSR, so we just want to take up the background of what Husky. So we are in the leader injection molding equipment services. So we are leader in the hot runner and controllers. So we work with the mold maker converter, and brand owners. It's very important to work with any of the areas because with the brand owners, even some product development status, we will be able to work it out where it will be delivered with to converter and also to the mold maker. So we have a standardized engineering and manufacturing process as well for that. Coming to the global network, we are covering almost like 146 countries where we have a 42 live offices and we have a 4 manufacturing location and there are some other tech centers. These all owned by Husky. We don't have any agent in the world, so we are Husky people, and it's very important when you do the critical and confidential project. This is the network which you can believe in and you can start to work on. And coming to the Husky product, hot runner, this is for everything, whatever you need it, whether you need a pilot mold single drop or you need a small cavitations productions molds, and if you need a high cavitations. And if you think about high cavitation, we are able to do it about 192 cavity with a part weight of 0.1 gram. And if you see the engineering material, start from LCP or PEEK or PVC or BBT. If you talk about fillers, you can do it mineral filler, carbon filler, metallic fillers. So there are a lot of the things which involves, especially hot runner selection, where we love to work with you guys. And apart from that, for increasing the manufacturing, we able to do it the stack mold with multiple products. Yeah, next, Balaji. Yes. And on top of that, we also come out with the angled manifold system where you can do the angle gating and drop-in system, especially we call this a PD wire system in the automotive and large consumer electronics and white goods spots. And very important, we have a side gating technologies with leak-free side gate and design-free, which means that you don't need to have any special design to accommodate the side gate. With this technology, you can remove almost any of the runner in your product, in your mold. And on top of that, we also have ultrasonic injection control technology, which is completely a disruptive technology today, which can mold whatever you think it can't be molded by injection molding. To control with all, the hot runner temperature controller is very important product where it gives you an accurate output of ampere to control the temperature, which is very important when you talk about the very fine product, very critical product. So we do have a simple hot runner controller, and we do also have ultra sync, which is electric driven controller, and also like individual wall gate controller, servo wall gate, and also we have a sequential controller. On top of that, we also come out with mold action servo controller, which is one of the key product today in the market. You might be having in your mold a lot of core pulls, retraction and unscrew mechanism, which is covered by today's hydraulic. The world is moving now with the servo motors. When you have a move the servo motor, you may be required multiple interface which need to be controlled. With this Husky new innovation, you could be able to control like at least the 7 axes of your core pull or interaction along with single controller along with Husky wall gate system. So this is one interface which is able to control all the operations with the one servo connections. And it's very important that whatever you are investing today, it should be a people behind the product and it should be behind with you, handhold of you for the service, refurbishment and conversion based on the market needs. And also it's very important that the people are moving. There is a lot of changes in the people. So it's important to have on-site training and repairs. And on top of that, we also do a call center where you can have a quick technical support from us. And then also we started launching up the e-commerce, which you can simply configure and you order through the e-commerce platform for a standard 2-drop, 4-drop, and 6-zone controller products. So with that background of Husky Technologies, the story of innovation and the product, the market what we serve. So we like to bring you today for a new things, which is the liquid silicon rubber, which is very important to have a precision quality, and also it's very important to have a continuous efficiency. So let me introduce my Balaji once more time to take you guys through all this liquid LSR presentation And end of the presentation, Balaji, we already started to have some questions. We expect more questions, so we will start to take some questions at the end of the session. Thank you, Balaji. Hand over to you.
Thank you very much, Rajan, and good afternoon, everyone. So the introduction is already made. My name is Balaji, and basically today we are talking about liquid silicon rubber. These are the applications and benefits of the industry today. So first and foremost thing, I would like to just to make a brief about what is this LSR is all about. This liquid silicon rubber has a different material grades. It's not only one grade, similar to thermoplastic, we have different grades, and eventually we have application properties similar to elastomers and rubbers. So this LSR is pretty much very flexible in shape, which is evidently important to the medical industry in particular today, taking an example for oxygen mask, just to let you know, increasing in popularity in multiple markets as well. So going into in-depth of liquid silicon rubber, this material itself is very much outstanding in biocompatibility, superior durability, flexible, and it's tear resistant. Wide operating temperature, this refers to having the cold temperature of resin itself, that is, which I will be explaining in the future slides, ultraviolet and chemical resistance, and electrical and mechanical properties induced, transparency and pigmentation. So going into the different features of these applications that can be used will be for medical, automotive, food production, electronics, sanitation and household, infant care, and engineering. So it's kind of covered into across all the things that we are coming to day-to-day scenarios that LSR can be used. So we can say that the market potential for LSR is taken about 40% in North America, and we in Asia Pacific are really growing well. So we have an estimation of $4.2 billion by 2028 globally, and with a CAGR of 9.25% during this period, we are very much looking into medical industry, which is really growing in the Asia Pacific with our population growing as well. So there will be a continuation of improvements to making sure that LSR is a market that we need to penetrate into today. Coming back into difference between plastic injection molding. So this is a comparison between thermoplastic and liquid silicon rubber. So it is no different between thermoplastic and liquid silicon rubber when it is to having a mold as such to be set up onto the machine. So we have two different cavity and core, similar to thermoplastic. It's having a single point of entry of the resin to be flowing inside. The shot volume and the flow will be controlled by the machine barrel itself. Just the difference will be that I will be happening to having, it's the repeatability of a continuous cycle, that the mold, in this case, if I go to this slide as a material chemistry, that is having a temperature and cavity control, cavity pressure expectations, thermal expansion considerations, and cavity fill balance control. So these are the differences that I go back to this slide one more time to just let you know that when we have this difference of solid part leaves the open accessibility cavity. So the difference is that we have to have these 6 comparisons to making a complete difference from thermoplastic to liquid silicon rubber. All right. So what are those differences? I just want to have a difference of comparison as an example. The thermoplastic, I take an example as a chocolate. For example, I have taken this out from the room temperature or from the refrigerator. I keep it in a heat, a sunlight, for example. Thermoplastic gets into hot condition and it liquefies. And when I put back to room temperature or the refrigerator, it turns into solid state. But whereas LSR, it's something similar to thermoset. We can take this egg as an example. Before heating up the egg, we have a liquid inside. But when we heat up, it solidifies. And in no way we can able to change it again to liquid. So in simple terms, we can say that LSR is considered as thermoset plastic, and thermoplastic is generally, it can be recycled to some percentage depending on the quality of the product that you need. Here, I have to put another example, like basically for the thermoplastic, we have a hot resin that is from pellets. It crushed into liquid sort by the injection screw. Then it fills into the hot runner or the cold runner itself of the mold, and eventually the mold will be putting up into a situation where the mold is cold. or hot in some cases of engineering plastics. It's a complete opposite when it comes to liquid silicon rubber. Liquid silicon rubber turns into a kind of A and B constant. Liquid silicon plus rubber goes into 50-50% as together. Mix it up, it's a homogeneous way, put it into the same barrel at a temperature of anywhere between 15 to 30 degrees as the resin. So gentlemen, here I would like to emphasize that thermoplastic is always the material is hot depending on the resin, but here LSR is always cold. But the mold is always hot in LSR. Why? Because we need to have that flow to fill up the profile, and it's never going to change its status. Once it's molded, it's not going to change anytime. We cannot able to recycle that one. So another example that we have to put up that's very critical way is that for thermoplastic, the processing of running the thermoplastic is that we need to have heaters, we need to have thermocouples, we need to have running cold, hot cold, or hot oil, something for the thermoplastic material to run. Whereas for the liquid silicon rubber, it's always water cooling. It's very critical. And of course, we need thermocouple for this one to maintain the temperature of the water. I would explain to you in the next slides to come. So what's the cavity pressure expectations that we can have with respect to LSR? LSR flows like water purely because it's very much low in viscosity. So it's very critical to making sure that the mold manufacturer that is going to run this one will have a very high quality of manufacturing processes so that our putting lines are all pretty much done so it doesn't flash. It's similar to go back to the thermoplastics, which again goes a difference in MFIs that depending on the different thermal MFI we have, injection pressure will be definitely higher than LSR purely because it is having having higher viscosity compared to LSR. So here I would like to share about thermal expansion considerations between hot runners and cold runners. Cold runners is nothing but cold deck that we are supplying. Either we complete a complete system like hot off, what you see on the left-hand side, versus the cold deck. We also come with plates, or without plates, we can able to introduce them. So in hot runners, basically, we have hot material, we have cold containment, cold cavity, increased load. So what does it mean? Hot material, basically the resin is always hot in a hot runner system. Cold containment refers to the water cooling that runs through cold for all the things, a cold cavity, and most importantly, increased load. Increased load with respect to injection pressure. In cold deck, we have cold material running through the manifold. Cold containment, again, the cavity is hot in this case, and the injection pressure is significantly lower compared to hot runner. Because it flows like water, we don't need a significant amount of injection pressure in this case. Again, a certain things that I would like to say is that in a hot runner, the temperature of the hot runner must be controlled to making sure that our products is not getting degraded with respect to the resins. PC, for example, polycarbonate, then polypropylene, then PET, and all other engineering plastics, to making sure that this is controlled by a controller. That Husky Rajan has already explained about our Husky controllers, why it is so important to communicate between the heater and the mold itself with the controller. But whereas in this case, the cold deck is completely maintained by the mechanical process with full throttle. That I would be explaining to you why it is critical when it happens to balance between the cold runner and the hot runner. So here we are talking about benefits of direct gating. What I mean to say here is that we all know that on today, we for the thermoplastics, we do a cold runner, we do semi-hot runner, and we also do direct gating. But considering an example for semi-hot runners, for example, these runners at all the time, let me get the pointer, please. So here, these runners, which are basically that I'm highlighting on the pointer, is that this goes waste. It will be a scrap or it will be recycled. The same on this side as well. The product, the two are going to be used, and these are all recycled. So this involves a significant amount of cost and low compressibility and all those things every cycle. So having said that, what we want to do that we want to eliminate, we have introduced direct gating, and this introduction of all the materials that goes from the thermoplastics will be recycled and used back to some percentage. So that depending upon the grade and what kind of product that we can able to utilize it. The same coming back to LSR, for example. In this case, runners cannot be reground and reused. Why? Because as I said earlier, for LSR, we need to making sure that this is basically a thermoset plastics. And if we are going to use hot to cold application for LSR, the runners will be a significant cost and it will be scrapped. So what we have to use here is that we need to making sure that the material savings is very important, direct material cost, and also the material use distance, runner handling will be influenced. All those things, even from the thermoplastics point of view or kind of to LSR, we recommend to go with direct gating. So direct gating with LSR, cold deck considerations. Here, we need to make sure that the requirements for the LSR, they are protect the liquid silicon material from heat, minimizing cross-linking, ease of maintenance and extended interval, cavity balance, adjustment and control, monitoring and prevention. So end of the day, we have to talk about this critical point of how we are going to define or design a nozzle features for the LSR. If you look into the screen that I'm highlighting here, basically the one in blue, these are waters that's run through the nozzle housings and eventually it's having a spiral cooling, it transfers and goes back. So all the material that having inside this blue, the green is the material that flows through the inside. So we have the nozzle water jacket and we have valve gate and conical shutoff. And this is the shutoff, the conical, that the valve stem that I'm referring to. And we have individual thermocouple monitoring. So you may be asking, why is that when you're running a cold water, you need a thermocouple? The answer is very simple. In the event of any blockages of water into the channel for some calcium deposit or flow rate is not right and everything, we want to prevent this happening from having any kind of problems, so that we introduce thermocouple so that the temperature is always maintained and it detects that something is wrong on that particular nozzle and easy to maintain, to remove and put it back. So that's why Husky is the only organization today I can say that having a thermocouple that has been introduced for LSR, which is very, very critical. And coming back into our gating location, constant contact with gate. So as I just told you before slides that constant contact with gate, what I mean to say that is here, the cavity always is hot when it comes to LSR mode. It having a temperature of anywhere between 120 to 180 degrees for the mold temperature. Whereas in this case, we have low conductivity nozzle tip, which has to making sure that the X, Y, and Z axis is clearly calculated in terms of MPI that we run for the mold flow, so that it is actually connects and contacts with the cavity and there will be no leak. This is very critical to making sure that Husky will take extra initiative working with the mold maker, the molder, and the OEM, that we do not go wrong. We have a first time right approach for this one. And most other thing, the last one is that balance adjustment geometry. This I'm going to cover it in the next slide. So here you are going to see the three section views of the valve stem movements that we have in here. Now on the left hand side that I have a cursor that I have pointed out, the valve stem is all the way back. The center one is just about lower than the one on the left. And the third one at the end of the thing is that completely going down. What does it mean? It means that we have this amount of plastic of different resins being accommodative inside when the valve stem is at the back condition, when the resin is flowing front. So this opening stroke that we run through, the difference between hot runner and cold deck is that hot runners always has a complete valve stem to move backwards in tandem to making sure that the plastic is flowed in balance. But whereas in LSR, because of the injection pressure is low, there could be a different of shift in plastic pressure. That being said, we need to adjust that one mechanically. So how we are going to do it is depending upon the mechanical controller that we use to set one time. So that being said, we can able to adjust and we get to have this balance. That is the reason. So coming back to the critical importance of the manifold. This is something that which is always been required, that you never see that in Husky's hot runners. Only in cold deck we have a split manifold, purely because these are important. LSR is easy to be maintained, easily to making sure that all these ones are, the number of screws that you see is to making sure that it will not be having any leak. So the water cooling is very critical for LSR, as I explained earlier. A geometrically balanced flow layout. If you look at that, all these things are evenly positioned and balanced, all of them. And then for the split manifolds, to fast and easy to clean. So these are all the important things that the geometrically balanced is starting point. Otherwise, as I mentioned to you earlier, this will not be having a kind of scenario like normal hot runners that there is no room for flashing for LSR. Even if we have a gap of 0.02 mm, it's going to flash. So that being said, it's very critical to making sure that this is aligned. That is why we have a number of screws here, everyone, to understand. So there comes that my quick brief summary of liquid silicon rubber. And here is the introduction of reaching out to us. My boss, the Vice President, Mr. Kashi Rajendra, and myself available with this. You can take the pictures or whatever, and eventually we make it up. If you have any questions now, I would be, and along with my Vice President, we are happy to answer you. Yes, thank you very much.
Thank you very much. So we have a few questions here. Why do you think LSR is becoming more prevalent in our molding industry?
See, today, as I told you that, in the past, we were not having any concentration about liquid silicon rubber. Liquid silicon rubber became very popular over the last couple of, let's say 5 to 10 years back in the 10, and now it's very, very popular purely because it is the thing that it can be used in wide industries, everything. And it is a kind of scenario where we do not have a kind of situation where we need to recycle. This would be kind of how much amount of recycle to be done and all those things. And it is cost effective and easy to use and very much compatible to making sure that it comes into medical industry and across the board. So with this wide variety and the cheaper product, the one-time investments, it is being considered to making sure that it is good to go today for the industry.
We have one more question. Can you further explain the design considerations when insulating the cold deck from the mold?
Okay. So basically, as I said, that for the insulators to having the thermal expansion factor is very, very critical for the cold deck. So what happens is that when we are considering the thermoplastic mold, it's the same concept to be introduced depending upon what type of resin are we going to use and how much thermal factor is being considered. But whereas when it comes to liquid silicon rubber, the thermal expansion factor is calculated depending on the flow and the profile of the plastic. So it's very critical for us to work with the mold maker to making sure that we have the complete design data for the cooling layout of the mold makers to having done through and ourselves to run the MPI. That's the mold flow for the expansion factor. It doesn't leak. There is no compromise. I told you that anywhere, even for 0.02 microns of this one, it's going to leak, or 0.002 itself, for example, not 0.02, gentlemen, sorry. So it's very critical to making sure that the thermal factor is very critical from the cavity as well as for the cold deck to align and to making sure that. So this design factor will be worked upon with Husky very closely with the mold maker. I think I have answered this question. If this is what is this one, yes.
Okay, we have a question from Mr. Bhaskaran. He's asking about how about the wear and tear rate of hot runner spare parts compared with the thermoplastic?
Oh, this one we will not have any kind of wear and tear just because, as I said, that the viscosity is very low. And the only thing we need to consider is that if Husky is going to design the system working with the mold maker and the thermal factor is critically designed properly, this runs for a longer time. Of course, there is a warranty terms and conditions applied, but that comes on the commercial aspect. But when it comes to running the system, it's very easy and it runs for a longer time.
What is the maximum temperature it can withstand, and can we use it for the inside engine?
No, this basically cold deck itself, the temperature, the material itself runs cold. I told you a couple of slides in the starting that this resin LSR comes with silicon and rubber, a 50-50 range, A plus B. Put it into the barrel, that will be running anywhere between 15 degrees to 30 degrees C temperature. That's it. Whatever the flow is happening is nothing. There is no material heat involved in this one. Whatever the heat involved is on the mold. So depending on the profile again to fill up, if having a more rips and all those things from the technical capacity, this runs higher temperatures so that the resin is going to flow properly to the mold. That's the critical aspect.
We have another question, which is why is stem control important?
Stem control is very important purely because, as I said, for the thermoplastic hot runners, we have a synchronized valve stem movement happening either between ultrasync technology from Husky, or we are going to go with air, or are we going to go with hydraulics. all the things is going to happen, and we guarantee a balance of 90% by default, that filling at 95%. That is for the hot runner, that is thermoplastic. Coming to LSR, why we are this cold deck is a runner system, valve stem is important is purely because, as I said to you, we do not introduce high injection pressure here. So even though when we have an even balanced flow on the manifold, when the material runs to the nozzles, it is important that this material on, for example, or a 4-drop or a 8-drop, that we control this balance flow of the, because the injection pressure is always set on the machine. Based on that injection pressure, the plastic is always flow in that direction. So we need to have the valve stem control for the one time to making sure that to run the only fill material at 95%, that this is set and we lock it up and it will never change at any time. That is the reason it's very important to making sure that the valve stem control is important mechanically.
Okay. Another question from the audience is about, should the water be cooled to protect LSR or the normal water or chiller water?
Yes, it is the normal water that it is going to run through to making it up. Chiller water is not really necessary, but no harm in doing it, because so long do you have a dehumidifier to making sure that there will be no sweat.
We can take one more question. How is the system maintained? How does LSR cold deck maintenance compare to conventional hot runner maintenance?
All the systems, whether it is a kind of thermoplastic hot runners or liquid silicone rubber, everything needs maintenance. So what happens here is that for liquid silicone rubber is very much necessary to making sure that periodically, as and when, depending on the cycle count, how fast it's running. So this is important to making sure that the resin is always cleaned thoroughly, because of it's very tend to degrade sooner if allowed for a longer time to be keeping. So that is why Husky or any others of Husky is making sure that we come into split manifold design, purely because it's easy to maintain. All we have to do is we use a liquid, a lint-free cloth and acceptable medical industry grade cleaners for all the channels to be cleaned and assembled back. And all I tell you is that the maintenance of difference of timing between hot runners and cold deck is that cold deck is the fastest way. I can say within less than 2-3 hours, we can able to set up and making it up run even on a bigger sense of to 16 drops, whereas it takes about half a day to 1 day to run only for hot runners to remove. That's the big difference.
Okay, it's another question from Mr. Dandapani.
Yeah.
What type of gating system suggested for, do you suggest for chain guides molding used in timing system for automobile material to be PA66 and PA66 50% GF?
Yeah, Balaji, I just take up. Just I
Yeah,
answer.
sure.
I would now to explain with the other audience as well. So the question was, what is the system we can do it for a PA6 and PA66? So for your information, guys, so we have been doing almost like a 60% of our resin today is engineering resin, which is having like a 6,000 to 7,000 system annually. Coming to the engineering resin is very important to select the right technologies. So we advise basically to deal with our local sales support team, where we could drive you the correct gating technology. So coming to this filler, we normally recommend to go for wall gated, so that the mechanically open stem and then the molded plastic can inject, and we can set it up so that the plastic property and your part quality would be controlled very nicely. If there is no direct part and it's a small runner, and then it's advisable still wall gate. If there is a commercial thing it doesn't fit, then still you are okay to go for an open gate, where we will supply a thermal screw, which can be controlled through the cooling, and then cut it out with the runner. So the most recommendation is wall gate, and if not, is open gate, but it's not direct to the part, it's a thermal screw. Thank you.
Okay. Another question is, do you supply a valve gate system to any suppliers in the Coimbatore region?
Yes, so we do supply with many customers around India, and especially coming to Coimbatore, there are many customers using the wall gate, open gate, and I have answered the customer name also to the audience. Okay, thank you.
Okay, one more question. And this is the last question. Any recommended water flow rate per minute for cold deck, or do you supply air kit supply? Does Husky supply air kit for the same?
Well,
It's depend on the part requirement. So we normally review the product from the resin point of view as well as the product design. So based on the requirement, we can recommend either need a air kit or not required.
LSR screw barrel is equal to the thermoplastic injection molding screw barrel, or are there any differences?
Well, the screw barrel that is going to run through will always have, it is not a set end process to making sure that the screw barrels are used. Yes, we can able to have it. It is having a dedicated sequence to run through, but all I can say is that we can work with the machine supplier to making sure that the screw is important to have a homogeneous mix, because we are running through liquid inside. So it is pretty critical that we, as a Husky supplier today, we work only on a cold deck. But with the mold maker and the converter and the OEM, we can able to work through them for that. We're depending upon, because if you have the larger screw size, there is a chances of contamination. So we need to have a right amount of screw and volume. Yes.
We have one more question that has come up. I think we have a little bit time, so I am taking the liberty to share this. Is there any difference between LSR runnerless system and cold runner systems used for rubber injection?
No, liquid silicone rubber, I said the advantage, the very webinar today itself is to say that we need to have runnerless system purely because we save cost using direct gating. And if you have a runner to the LSR, this runner will go become a scrap and it will be a significant cost involved for that. So today, LSR is very moldable to every kind of profile to making it up. So having said that, it is always recommended to go with direct gating.
Yeah, so just to add up the answer, the question it's kind of like in the rubber injection molding, many people using the cold runner because it can be recyclable and reusable. But as per Balaji technical presentation, in LSR you can't do that. So that means whatever the amount of runner you're going to produce, it's going to be waste. So it advised to have as much as possible runner-free LSR mold design.
Thank you, everyone. Thank you, Mr. Rajan and Mr. Balaji, for giving this wonderful presentation. And thank you, audience, for joining us for this webinar. A very insightful webinar. Thank you, everyone. If you have any more questions, do feel free to mail us, and we will make sure that you will be getting the responses from the Husky team. Thank you, everyone. Have a wonderful evening.
Okay, thank you.
Thank you.